Welcome to the Black Sparrow Media Internet Broadcast Network.
You are listening to Linux in the Ham Shack. LHS is a podcast about Linux, open source, and amateur radio for everyone. Now here are your hosts, Russ, K52UX, Cheryl, W5MOO, and Bill, NE4RD.
Well, hello everybody, and welcome. You have tuned into episode number 387 of the most terrific amateur radio podcast on the internet. This is Linux in the Ham Shack, and we're well on our way into the new year, 2021, and this will be our first deep dive episode of the year, and we'll be talking a little bit about building things on your computer, building things with your computer. Anyway, doing some building, and hey, don't laugh at me. I'm trying to waste some time just because our content is light.
Oh, we'll find a way.
I'm sure we will. Yeah,
we'll be going.
Absolutely. So the normal cast of characters is with us tonight. I'm Russ, K5TUX.
I'm Cheryl, W5MOO.
And I'm Bill, NE4RD.
Luckily, those pops show up really easy in the waveform, so easy enough to edit out. But that's all there is for the introduction. So now we're going to try and get into the meat of it. And I put up a description of our deep dive tonight as setting up a proper build environment. We might be striking through the word proper at some point, but we're going to talk about if you have a Linux system and you want/need to build some package from source code instead of using a prepackaged binary file or binary package. We're going to talk about some of the ways that you can set up your machine to be ready to handle that, whether you're using an RPM-based system, which Bill's going to handle more than me, because it's been, a little while since I've dealt with Fedora / Red Hat / CentOS / Scientific Linux / whatever.
It's not much different.
It's not much different. There are a few differences, and we'll go over those. But I use Debian / Ubuntu mostly, and the prepackaged packages are deb files, as most people are aware. But you can also build things. You can download source code. But in order to... What was that?
That was me, sorry. I was like, oh, scary source code. Ah.
Yeah, I mean, once upon a time, everything was source code, and there was no other way to get software onto your system without it. Things have advanced since then.
You could just run Arch and then everything was source, right?
Well, yeah, Source or Arch and Gentoo, and what else? What are the other purely source-based distros? Those are the two big ones nowadays.
Yeah, build your own Linux. What was it? Linux from scratch.
Linux from scratch, yeah. But that's even going. That's like putting the horse before the horse, because that's like you have to build the actual.
Build Linux before
you have to build Linux else. Before you can build anything on it, right?
Oh, Arch is not like that, but like the AUR package system is basically building everything from source in the packaging system. So
right. So let's talk a little bit about setting up a build environment, and we're going to start with the Debian side of things. And let's see, I started off with ways to get source packages as opposed to setting up your build environment, because in order to build something, you have to get the source code. One of the most popular ways that you can get source code these days is using Git, because GitHub and GitLab and other places that store source code repositories use Git as a protocol for storing and allowing people to make changes to and just keeping a repository of source code data. And Git and its earlier companion, I guess, Subversion, are ways that you can interact with those repositories to download source code. And what's nice about them is they actually keep the source code updated. You can do polls periodically, and that will like update any source code you have on your system from the repo. And then if you're building out of that repository, you'll have to rebuild the software with the new pull code, but at least it will match. It will keep your local copy of the source code current with the master source code. So Git and Subversion okay.
I was going to add with that too. Yeah. that Git will also allow you to get a certain tagged version, like very specific versions or very specific releases inside of the software repo as well. And you'll notice that a lot of build files and stuff like that, when you go to build something, actually uses Git to go download additional repositories to build stuff. And they'll be pulling down very specific versions of the repository that their software needs to be built against. WSJTX comes to mind because it actually does pull 2 Git repos in the process of building the software. So Git is kind of pretty critical these days in your build environment, and almost certainly is almost already there. I can't remember if I had to install that or it was already on mine.
On most of the systems I build, I always have to install Git. So it's very rare that Git comes to predefined. Like some Debian installers will run the task cell command that gives you like a checkbox, a list of checkboxes of things you can install. And I think Developer Tools is one of those options, which will do things like install Git. But generally speaking, by default, at least on Debian and Ubuntu-based systems, Git is not pre-installed, at least in my experience. And maybe I just gloss over it, but I install a bunch of packages by muscle memory whenever I create a new machine, and Git is like one of the first things I always install. And I don't know if I bother to notice whether it says Git is already installed or it actually installs it. So, yeah. Yeah, we're talking a lot about Git. It's making me giddy. So, yeah, Subversion is an older version of something that does exactly the same thing, and I've noticed that very few people these days seem to use it. But it does the same sort of thing, and if someone is maintaining their source repository in a Subversion repo as opposed to a Git repo, you'll have to know how to use it. It's pretty simple. You just have to apt install. Is it apt install Subversion? I think it is.
Yes.
Even though the command is svn, the package is Subversion. So that's how you get your source code, or at least some of the ways you can get your source code. Other ways are just to go to a website and download the source code as like a tarball. I mean, that's pretty common as well. That's how WSJTX does it. I think that's how I did it. I don't remember them having a Git repo. They probably do, though.
No, in the build file, when you do the making side and you get your make files, it actually goes out and it grabs the repos in the process.
Right. So it's a tarball.
The instructions to go use Git are inside the tarball.
Well, that's useful, especially if you don't know how to use tar. Now, that's one thing that we didn't talk about here is tarballs and encrypted or not encrypted, but compressed archives. Are we going to assume everybody knows how to extract a compressed archive?
Yeah, I think that's a pretty safe assumption, considering if you just double click it, it'll extract it for you automatically. You'll bring up the archiver and you just hit extract all. And yeah, I mean, that's pretty easy. Obviously, you can still do it via the command line, but we'll just consider that an edge case.
Yeah, and on this list of things, sort of before you get to building things, you might want to make sure your system has things like tar, which should definitely be installed by default, but zip and unzip probably aren't. So you might want to install those just for, grins. And even if unzip is installed, zip probably isn't. So that's something you can put on your list. But then once you've got a repo that you've downloaded and you want to build it, or even before that happens, at least on Debian-based systems, one of the great meta packages they've created is one called Build-Essential. And I'd say if you plan on building software ever on your machine and it's a Debian-based machine, you should always install Build-Essential. I did not list all of the things that are in or referenced by that meta package, but it's quite a few things. Compilers, libraries, preprocessors, lots of things you need to build things. That's kind of the whole point. But in my experience, it does not install everything you might need. It makes some assumptions, and of course there are lots of toolkits out there now, like Qt and Tickle, and I don't know, lots more that I could probably name. Fastlight to give Ted a little sunshine because he likes to use Fastlight. Wait, is it Ted that uses Fastlight? No. Who uses? No, FLDigi does. FLDigi, that's right. So, yeah.
FLRig, that's uses the Fastlight toolkit.
Fastlight,
FLTK.
Yeah. Sorry. Ted uses his own stuff, which I think is
Motif.
It's Motif or Motif. Yeah.
Motif,
that's right.
Yeah.
Motif. Thanks for reminding me. Okay, so anyway, we got to talk about Ted anyway. But yeah, there's lots of toolkits out there, things like Motif and Fastlight and Tickle and Qt and all that stuff. And if you're going to build things with those, you're going to need those libraries and build environments on top of the things installed by Build Essential. But those are kind of like individual use cases. And for the most part, if those things are necessary, there'll be a README in your source code that will explain to you what you have to install or what dependencies you need. So yeah, the first thing you should do is in your source code, once you've extracted it, you should look for files called like README, readme.nd, install. These are usually all uppercased, and you'll find you should find a lot of helpful information in those files that will usually list things like packages you need, dependencies you need, the actual commands you need to type to build the source code, so on and so forth. So make sure you check those out first.
In WSJTX, they have an install file, all caps, and on Linux, they say the first thing you need is build-essential, which, of course, is the meta package inside of Ubuntu.
Ted in the chat room mentioned header files, and I'm curious where he was going with that. Yes, header files are definitely part of any build, but I was wondering if he was mentioning those as something relevant to someone who's building something, because, I mean, if you don't understand the source code and you don't understand the language it was written in, you don't really need to look at header files generally, but I'm curious why he mentioned that. So
I don't know. I rarely ever look at the source code myself.
Yeah, I rarely.
Unless I'm like that concerned about it.
Which are the header files? Well, they're the library files. I mean, specifically from like a C environment, you generally have .h files, which are header files, and .c files, which are compile files. The .h files are like references to things like variables and libraries and dependencies and stuff that the compile files actually need to do builds with. And then the actual code is the .c files. So yeah, the dev files and the devel files, that's something we're going to get to in a minute. But I consider maybe I'm wrong about this, but I consider the -dev files the library files, not the header files, even though they sort of are. But I'm separating the shared stuff, which is in the dev files, with the software author actually wrote, which is in the local source code in the directory that was in the tarball that you uncompressed, all that kind of thing. There's probably not a necessary distinction there, but I don't know. That's just the way I think about it in my head. So I guess we'll go with that. So once you've installed Build Essential, which like on a Debian machine is apt install build-essential, there's some other packages that I always install just because it usually makes life easier when you're building something. And those are AutoConf and AutoMake. Those are tools. Oh, and libtool as well. Those are tools that go through scripted, I guess you could call them like a make file and a comp, and these AutoComp files are kind of like recipe files to sort of set up the build environment to properly build. And you need these tools to be able to read the necessary files to set up the build that you will later use a make file or an actual compiler file to turn the source code into a binary. There's also some other ones that are other pre-processing engines or compiler preprocessors. Basically all this stuff that happens before the actual build starts. There's one called Yak, which is, I believe, yet another C compiler, which has morphed into Bison, which is I believe the C version, and then Bison++, which is the C++ version. And then there's Flex and M4. As far as I know, both of those are not used terribly often anymore. But these are all like script parsers and macro parsers and other preprocessors that will take the necessary recipe files to do the work before the work in order to set up your build properly, so that when you get around to typing make, everything goes off without a hitch. And generally speaking, these days, if you're going to be building software, make is your like holy grail command. When you've done everything and you get to make, that's when you see stuff happen. And in a lot of cases, you'll see a file in your source repo that's make file with a capital M. And if you look in there, you can see the recipe. You can see what make will actually do. And in there are sections and they have headers. And it's basically just a recipe of what's going to happen when you type make. And it's like which libraries are going to be called, which options are going to be called, build options, which libraries need to be linked to, et cetera, et cetera, et cetera. So somebody went through all of the trouble of putting together a recipe for how all of this stuff is going to turn from a bunch of raw ingredients into a compiled binary, so that when you type make, you don't have to know about any of that stuff. The author actually put it together for you. And so if you're lucky and you have all of the prerequisites installed and all of the libraries you need, when the make finishes, you'll actually have the compiled binaries to run these applications that you want, like WSJTX or whatever. And then usually that's followed with a make install, and the make install is just a recipe for where to stick all the binaries you just built on your system. And generally speaking, in a built environment, they all go into /user/local. That's pretty standard, and I hate it. I don't like the fact, because like on a lot of systems, if you've been around in systems administration for a long time, user local is under user, and very, very rarely on systems do people create a separate partition for user local. So that will always wind up under /user. And so if you need to remove or somehow access all of the built stuff on your system, as opposed to like the stuff that was installed at the very beginning, the sort of standard system files, they're very hard to distinguish other than the fact that they're under local. So a newer concept, I think, is to use /opt, OPT, which is short for optional software. And if you look through most make files, they will give you an option or command line switches, usually specified with like -D, capital D, or -- prefix or something like that, where you can specify, we didn't talk about config, did we? We just kind of skipped over config.
Yeah, when you were mentioning auto config, auto conf, you kind of passed over it.
Right.
Yeah.
So right before you type make, usually you have to type a command called configure. And that sets up the make file, and it allows you to tell the build environment that you want certain special parameters if you specify them. Otherwise, it will just set up whatever the defaults are. But if you do like ./configure, -- prefix equals /opt, for example, that's pretty standard syntax, then it will install the software when you do your make install under /opt instead of the default, which is usually user local. And I find that generally more palatable, because at least if you install all this built stuff under /opt, you know exactly where it's at. And it's very easy to create a separate partition for opt. I felt like you had something you wanted to contribute there.
Well, I was also going to say that if it's not a project that uses configure, it most likely uses one of the other tools like CMake, which is what is used for WSJTX. It does have some other additional switches for changing where you want the installation to be. It's a little bit more verbose. So it'd be like CMake space minus capital D, then space, and CMake _install _ prefix equals. It's why it's important that you read the installation instructions, because it'll tell you what you need to do and what order you need to do it in. And also what are some of the optional features and stuff like that that you need to do. Most of the time you can get away if you don't really care where it goes and you just basically want to get to the executable. You could easily just do, .configure, make install. Same thing with the CMake. It's CMake, and wherever your source is, you give it a path, and then you run make and make install. Now, it's not recommended you do it that way because there are a lot of, like you say, you might not want it to be installed in user local, bin and everything else, or you might want it in your home directory. You might only have permissions to operate in your home directory. You might not even be managing the box that you're on. Maybe you don't have root permissions or whatnot. So you might have to put it in your local directory, in your user directory, which is normally your username, /home/username/ .local. A lot of software is kind of installing there nowadays as well. So you'll basically find that as a target as well.
Yep, absolutely. Configure, make install. That's one of the great things about building software is usually that's all you need to do. The problem comes when you get to a point where somehow you don't have a dependent library and your build breaks. We're not going to do a whole long thing about how to fix that.
Well, there are a couple of steps. Like in the configure script or the CMake, it actually runs some initial stuff. So it can tell you right away if you don't have certain build tools.
Right. It'll
Especially
say like do
you're
you
missing
have
GCC, you're missing GCC Fortran, you're missing,
right.
so on and so forth. It looks for some very specific stuff ahead of time. So you can initially figure out what you need to get there, and it'll normally error out. It'll show the errors like you don't have this. It's not available. If your terminal has color highlighting, generally it's highlighted in a different color. So, it's not green. Green is good. And then red is bad and yellow is a warning. So you can get some hints right there before you even go into running make, which is actually going to run the build script and do the compiling.
Right. And really, really good make files will actually go down and give you a printable output that says was the Fastlight toolkit found? Yes. Was, the header files for a sound found? Yes. And then it'll say was the stuff for Flac, for example, found? No. And then you'd be like, oh, well, I don't have the stuff to build Flac. So at least it told me. You can also tell by the build output that you don't have a necessary library / group of header files. That gets us down briefly into package nomenclature. If, for example, Flac, let's say you're building something and you required the Flac library and it failed. Well, what package would you install to install Flac support? Now, generally speaking, this is not 100% of the time. Sometimes you have to just kind of Google for it. But at least on Debian-based systems, the file that you need will be whatever the library name is, prepended by lib, L-I-B, and postpended by -dev. So, for example, if you're missing Flac, you would install libflac-dev, or libvorbis-dev, or libfltk-dev, or whatever it is. That doesn't follow all the time, but it's a good place to start. And if it doesn't necessarily work out that way, you can always say, Google, what are the Flac library files for Debian called? And it will tell you what package to install.
Or you can you can use apt search and then type in Flac and it should pop up as well. So,
right. But generally speaking, the nomenclature is lib library name -dev, which will be whatever the header files or library files you need to build a certain component of whatever it is you're compiling. It's a good place to start. So we're going to talk about the differences between that and RPM systems in a little bit, because they are a little different. Let's see, what else do we need to touch on? I have in here preprocessor compilers, libraries, makefiles, etc. I think we kind of went through all of that. Yeah, generally speaking, the documentation for a lot of built software is really good. So it's a matter of looking at the README and the install and literally typing what they tell you to type. The biggest problem comes when you're missing a library. That's usually the biggest problem with getting a compile completed. And I think we've given you some hints for finding out how to install missing dependent libraries. If I think of any more while we're talking, I'll make sure to put that out there. And the other thing we were talking about, is building source packages. So there are repositories for binary packages in Debian and Ubuntu and repositories for source packages. And there's a command, if you wanted to install something from binary package, you just type apt install. If you want to install something from source package, you use apt source. And apt source allows you to give the -B flag for build, and it will build something from the source package rather than installing the binary. Generally speaking, you don't need to do this. Some people like to do it because the build might be tailored a little better to your system. So if you're looking for some slight performance gains, that might be helpful to you. But generally speaking, it's not necessary. And sometimes this will fail because you're missing dependent packages. And I believe you can specify the -F flag if that's the case. And what that is short for is fix missing. And that should install any necessary or missing dependencies if you're doing a source build.
That was force.
No, force is force, -- force.
Oh, okay.
And -F is -F fix -missing. So those are some ways to build source packages if you want to do that. And at least from the Ubuntu Debian perspective. So Bill is going to kind of walk us through a little bit how Fedora and RPM-based systems are a little bit different than that.
Yeah, I did want to reach back and just kind of go over one more time while you're in the process of running your make. And this will be the same in Fedora and anywhere else as well. If you kind of read through the instructions and you're like me and you kind of skim over some stuff, you may have missed a package. And this will happen occasionally. You'll get through, you'll be making and you'll walk away. You'll come back. It says, I couldn't find a sound or something like that, or I couldn't find the serial port package for Qt, and you're like, crud. So you go in there and you add your package. Most of the time you can add the package and just type make again, and it'll kind of continue the script. It'll kind of say, oh yeah, I built all that. But occasionally it won't build because it might be like in a crucial step that kind of buggered up the whole process, and it won't move forward on that. And sometimes you have to do a make space clean, which basically just wipes out everything make did and starts from scratch. So that can happen, and it happens to me all the time. So I know.
Sometimes make clean is useful, and sometimes it's make dist clean if you want to go all the way back to the beginning, like nothing ever happened.
Yeah. You can even wipe out all the make files as well if you have to.
Right.
But yeah, if you just run a make clean, it'll actually just start all over again, and it'll just keep going. And a lot of times I'll find if I'm too lazy to read the documentation, which is more often than not, I'll just have a series of make. Oh, okay, what am I missing? Okay, let me find that package. Make again. Oh, I got to start over. Make clean, make. Okay, I'm missing that package. Let me add that. I wouldn't recommend it, but it is efficient. It does work.
I've done that more than a few times in my life. Trust me. So, there was one that I think I had to install like 12 or 15 different libraries that the make file or the README file didn't say were dependencies, and you just kind of have to work through them one by one until you get the thing to finally install.
Yeah, especially if there's not like any good documentation. Yeah, sometimes they say, configure, make install, you're all set. Oh,
and by the way, I will put this out there just so people are not flabbergasted by it when it happens. Sometimes you can do a /configure and a make, and your software will build, and it will not work because someone didn't have the make file checked for something. The build process actually completes, but it doesn't, the resulting binary does not have a necessary library, and execution will then fail. That is a problem that you're just going to have to Google a solution to. It doesn't happen super often, but just be aware that it can happen. It's usually because of poorly documented software, but life sucks sometimes.
So yeah, getting back to Fedora now. So, they just made a change going from Fedora 32 to 33, which of course kind of blew up my idea of what I needed to do for the development stuff, because the old at system development and blah, blah, blah keys didn't work. So they have, Fedora has its own kind of group install or a meta package of tools that you need for doing development stuff, kind of like the build essential. And this one's activated by using DNF, which is the package manager instead of using apt for on the console. Group install, and in quotes, development space tools, end quote. And then the other group is called development libraries, and it's very verbose. It used to be in Fedora 32 it was like at development system and at development something. I don't know. I only did it a couple times, so I didn't have to put it to memory. But yeah, I was surprised to see that they changed it in Fedora 33, which is also kind of what required me to build WSJTX from source, because the build they have on the website for RPM download does not like Fedora 33. It likes Fedora 32. So I'm living in the cusp of versions for support in their build environments. But basically everything that you need for Ubuntu is going to be exactly the same as you need for Fedora for building applications. Sometimes authors are nice enough to actually tell you, hey, the package names are going to be slightly different, which they are. Like Russ mentioned that a lot of times if you have a library like Flac or Boost or something like that, it's in Debian land, it's lib boost dash something something something, or lib Flac dash dev. Inside of Fedora, it's most likely Flac dash devel, DEVEL for their packages, or it could be libflac dash devel. That looks like they haven't really made up their mind which the way they want to go. So you do have to kind of use the search utilities occasionally to try to figure out the naming convention. I believe, let's see, they, in the documentation, they have, the Qt 5 stuff listed as, Qt 5-Qt multimedia dev. And let me see what I have in mine. Oh, I'm on the wrong system here. That's why none of those commands looked right. Let's just look at the history here. Yeah, there we go. History. Yeah. So, Qt5-Qt serial port devel. So, okay. Yeah, they did get all those packages right. So yeah, you do have to kind of figure out the naming convention of various packages. It may or may not be straightforward. Sometimes, you might miss stuff. Like I said, go back and find it. CMake, yeah, all those are going to be straight names. So like when you're trying to get CMake or GCC-G4tran as a package, and almost all the other packages are going to be whatever library-devel. So not a huge amount of difference. Everything's going to build the same. There's not going to be any different new errors or anything different than Ubuntu or any other Linux system, because after all, it is Linux. They're all using GCC tools to do the authoring and compiling, and your make files are being built from the same stack of Automake or CMake or QMake. So you're not going to see any huge amount of differences, but the big difference between the environments are going to be in your meta packages for getting that initial build utilities kind of all pushed on there. Now you don't need to use that. You can just, sudo DNF install C++, GCC and everything else, manually. But I mean, they have these easy steps. So, you don't have to go through and try to find every single little tool, especially if you're just doing a one-off build. Like the only thing I have built on my system is WSJTX. So, I mean, I don't need everything else and all the other software if I'm not going to build a package that needs all that other software. So literally I went through and used the documentation for WSJTX and just installed those packages. And that's the only additional packages I have in the system. And that essentially should get you going for most of your building needs. And you shouldn't really be afraid to build software. like I say, you know, if you're missing something, it's going to tell you what you're missing. Generally, there is an occasion that you're going to get a weird error and you're not going to know what it means. But generally, if it's a popular piece of software, you're going to be able to find the answer pretty quick as to what you're missing. So I wouldn't be worried too much about that either.
I will. Let me interject here real quick. Here's something you can do if you built something and it doesn't run. And I'm not going into this because this is like a semester college topic. but a short thing you can do if you run into problems with a built binary is install a utility called strace. And once you've installed strace, you can run the binary with strace. You use strace and then the binary as an argument. So like, let's say you're going to run WSJTX, you would do strace WSJTX. Then it will run it under essentially a command line debugger. And what this is good for is if there's a missing library, like a missing link to a library file, like a .so file, which is a shared object file, it will tell you exactly which file it can't find. And that can be a great, easy way to locate a library that you do not have installed. It'll say something like, you know, libasound.so.2 not found, you know, before it crashes. And then you'll know you need to install, you know, libasound or something like that. So this can be a super helpful way, an easy way to identify some missing libraries or missing files or even a missing executable that something is looking for when you run it. But like I said, there are so many fathoms deep you can go into strace, and we're not doing that. But it's a good debugging tool and one that can be used fairly effectively, fairly simply, without diving in too deep. Back to you.
That's really all I had for the Fedora differences. And I can't think of anything else that's very specific to Fedora that you wouldn't encounter in Debian land or Ubuntu.
What is this DNF that you speak of? I thought it was Yum. Yum is everything, right?
It hasn't been Yum for a long time. So.
It was the last time I used Fedora. So
yeah, DNF is the bomb. It gets picked on for being slow, but it's been getting faster.
and also having a really crappy name.
Yeah, it did not finish.
Yeah, exactly. I think about all the skiing I watch, and every time I see DNF, it's like, oh, yeah, didn't finish. Anyway.
You can tell these are computer guys, not sports guys, right?
Yeah, exactly.
Wouldn't have used that for something so critical.
Don says he's only needed DNF and sent to us 8 and rel 8. And because before that, it was still Yum. Yum! Which is the... What did the Y stand for? I mean, it's the update manager, but what was the Y? Yellow Dog? No, surely not. I'm curious now because I can't remember what the Y was for in the update manager. It's not Yellow Dog, surely not.
Yellow Dog updater modifier.
Oh, it was. Holy crap, it was from Yellow Dog.
Updater modified. Yeah, Yellow Dog updater modified is what Yum stands for.
No wonder they switched to DNF.
Yeah.
All right. The only reason I ever used Yellow Dog is because it ran on PPC.
DNF stands for
did not finish. Yeah, we established that.
It's the other name is Dandified Yum. So the DNF comes from Dandified. Dandified, not damified, Dandified Yum.
Dandified. So what's the N?
I'm assuming that comes from the third letter, D-A-N. So D-N and then the F. It's all undandified. All three of those letters are in that order. Just, you have to drop all the vowels.
And drop the D.
The extra D.
Right.
And then, so just keep the first D and then drop everything else except for the N and the F. Then you're all set.
Well, great. So they've made the world's worst acronyms.
Yeah, I think it is. This is horrible. But it works pretty well. I mean, the only thing I don't have is an alias to use DNF as apt. So I could just say apt install instead of DNF install.
Yeah. What was the, does anyone remember Alien? Oh, you don't remember Alien? I want to see a show of hands in the chat room. Who remembers Alien? No, it's something very specific to package management in Linux. Okay, no one's even raising their hand. But Alien was a way to install RPMs in Debian. Here's actually a recent article.
How to install RPM packages on Ubuntu using Alien. First, you must install Alien. So you have to let the aliens invade? Oh, my goodness. Oh, that's funny. Yeah, so it takes the RPM and it creates a deb package out of it.
Right. It takes all the meta information and all the scripting and everything built into an RPM package and converts it to a deb. In my usage of Alien, which was few and far between, it never worked well. The concept was interesting because sometimes back in the day, software was only released, one way or the other, like it was only built for Red Hat or whatever. And Alien was a way to convert RPMs to debs.
That's very interesting. Yeah, I'm almost thinking I have run into this, but I probably cringed so bad. It was probably more useful when the systems were closer in parity with each other. You see a lot of kind of, Fedora hangs right on the edge, more closely than the LTS does in Ubuntu. So unless you're possibly on like the latest, whatever rolling build of Ubuntu, this is like now would be the 2010 build. And in a couple more months, it'll be the 2104 build. Like that's probably closer to what is the current versions that are currently running inside of Fedora package versions, at least. And yeah, you'd have to be pretty close because all your supporting packages, like, think about the read line issues with WSJTX switching between 1804 and 2004, even 1804 and 18.10. They couldn't go between that.
Alrighty then. So do we have anything else to say about setting up build environments on Linux systems?
No, it's easy. It's not that hard.
Or you can just run Arch and then everything's built and you don't have to worry about it.
Yeah, don't do that.
Yeah, we don't recommend Arch. Yeah, if you're going to run one of those things, run like Manjaro. Wow.
And I have blown up my system with Manjaro multiple times, so buyer beware.
Exactly. All right. So with that, we hope this has been at least a little bit. This is one of those ones where we're just sort of tiptoeing over the line into the deep end. There's a lot more to building software than what we covered, but this should definitely give you the idea of how to do it, and hopefully the idea that it should not be an episode of Fear Factor when you want to build something from source. It's really not that bad. If anybody has any questions about this or updates or wants to try building something from source and let us know how it went, that would be great. We'd love to hear about it. And if there's something we missed, please let us know that as well, and we'll include that in the show notes. But without further interaction from the peanut gallery, they're probably all wrapped up in that Alien article I posted. So we should probably move into announcements and feedback. And this first one I think might be directed at you, Bill, so I'm going to let you go ahead and handle it. And this one's a little on the old side, but we did have a break in there, and we have not really addressed feedback in some time. So apologies for the fact that this one got kind of backlogged, but we'll see how it goes.
Sure. Yeah, this email comes from Robert, N5 Bravo Sugar Bravo, or Bravo Sierra Bravo.
Don't do it. It's a good thing it wasn't BSD, because
yeah. Bacon, sugar, bacon.
Bacon, sugar, Doonesbury.
Hi. Hi. I've been watching your videos. I run a Raspberry Pi 4, and I have CQR log, FLRig, WSJTX, and Grid Tracker all working. Yay! My QSOs are being uploaded to QRZ and EQSL. I get a message stating that they are being uploaded to Trusted QSL, but I have yet to see any of them in my Logbook of the World log. The download test button passes, and when I test Trusted QSL button, it shows the version number. Just wondering if you might have any insight into this. And this comes from Robert Schindler, N5BSB. And I'm assuming since you're not talking about the pop-up when you're actually sending the results over to Logbook of the World, it's not automated. You actually have to click the separate little button, and that button pops up a dialog box that gives you any errors from WS or from I got WSJTX on the mind. Any errors from trusted QSL, encrypting the log or signing the log. If you have a password on your key, it should be prompting for you for that then as well. Like I have a password on my key. I just type in my password and it literally says inside the little box, has a little box under the thing. It says, if you see any errors, then read the errors. So there, if you're not seeing that box, then you're probably not going about sending your stuff properly out of CQR log. So yeah, if I bring up CQR log, which I do have to send some stuff out, so we're lucky here.
I may have to address this from the perspective of Grid Tracker, which might be what he's using.
Yeah, if you're using Grid Tracker and you have CQR log, I don't know what you're doing, because you should just do it in one place.
Well, Grid Tracker has if CQR log has the ability to upload to Trusted QSL or to Logbook of the World, probably should just do it that way. But Grid Tracker has that facility as well. And judging from the output of the diagnostics he said he did, I think he's using Grid Tracker. The only thing I would suggest, he said the download test passed and uploaded show the version number. That's what happens when you use it in Grid Tracker.
Oh, okay.
And the only thing I would say is, if in fact you're doing this from Grid Tracker before Bill fleshes out his answer from CQR log, make sure that you have a default location set in Logbook of the World.
Yeah.
That's usually where the issue is. Make sure it's set correctly, and then it should work. But if you're using CQR log,
it's exactly the same. I mean, literally, you need to have the QTH nickname in there, which is your location for the Trusted QSL certificate that you've named in your system. So make sure that's the same. And again, you have a full diagnostic window that shows you any errors and everything else, and the little upload button there. So it sounds like you said, it sounds like he's using Grid Tracker for doing that, which I'm not sure. I mean, I guess if it's easier to do that way. I mean, because CQR log also automatically uploads to HAMQTH, Clublog, HRD.net, or HRDlog.net, EQSL, and Logbook of the World. Those two push buttons.
Grid Tracker does all of those as well as CloudLog. Yeah, I just use Grid Tracker to upload all my logs. It just seems really easy. And then what I do is if I've had a couple Logbook of the Worlds that have been missed, so what I do is I download the ADIF file and then run it through Trusted QSL directly, and that fixes any gaps.
Yeah, I don't know. Can't help you.
I think we did, actually.
It doesn't make sense. It doesn't, it doesn't make a lot of sense, though, if you have CQR log. I mean, because when you're not doing, I guess you can use Grid Tracker for non-WSJTX QSOs as well.
Yes, you can.
Yeah, I don't know. It doesn't match my particular workflow. So, I mean, I just write everything on my side goes through CQR log. Even if I log it in, let's say a Windows computer or something like that on a whole nother computer, I export the log and I bring it into CQR log, and then that handles, doing all the QSL management and stuff like that. So it's always done in one spot. But if you're doing everything inside of Grid Tracker, I'm assuming you can do the same. You can import native from any other logging program should you log it externally. And then when you bring it into that, I'm not sure if you have to go back and then highlight the ones you need to send out, or if it knows that it needs to automatically send those out to confirm them. I'm not sure exactly how Grid Tracker works with that respect, because I've never used that particular function or feature.
Grid Tracker sort of only does it live. If you load data into it, it will not update it. Like it will be updated.
That would be very useful.
Right. It would be updated for Grid Tracker, but it won't update the other services. You have to do it manually.
Yeah. So yeah, unless you're only using Grid Tracker while you're only doing QSOs forever, it sounds like a bad idea to have that your only workflow. I would consider changing that. But that's probably enough answers, or maybe even some more questions for you, Robert. So let's just end it there. If you have any more, please send a question back or join our Discord channel and you can talk to us live.
Yeah, absolutely. We'll try and help you out as best we can. So moving on, we got an email from John, G7VRI. He says, and this was directed towards me specifically because I asked a question. Hey, Russ, a few days ago, I was listening to episode 380. Yeah, that was a while ago. Where you asked for help setting up Nginx proxying of HTTPS to HTTP. Don't know if you got an answer, but this is what I do. Here's the gist of my Nginx proxy stanza. I store this blah, blah, blah in Etsy, blah, blah, blah. I posted this to the IRC channel, but I'm not sure if it got lost in the noise. It did not. I just have not had a chance to try and implement it. So I'm going to do that. I'm trying desperately to find a way to secure the connection to the Etherpad because it does not support SSL natively. And it actually requires passing through of the actual URL because it uses the URL for part of its how it serves pages and everything. So I need to make sure that's actually maintained through a proxy. Yeah, it could just be a giant nightmare. So who knows? But anyway, thanks for the help. I will get to looking at that at some point, and I will let you know if it works or if it doesn't. And we're going to bring Cheryl in here. Yay! She hasn't fallen asleep.
Me fall asleep? Never.
All right, so these messages from Coase, and I'm going to let you read them and stop talking because I'm feeding back to myself. So there you go.
All right, bye. So our first email in this segment of them is from Coase, PE4KH. It says, I came across a serious case of Linux in the ham shack, and he has a Twitter link. Then he went on to say, FT8 signal implemented in Linux beep command. Hope you enjoy this. I'm still listening to LHS, but due to a certain medical situation in the world, I almost don't commute, and therefore the backlog in podcasts is huge. Coase, PE4KH.
I'm not actually sure I understood all of that, but I think that, the beep command, that creates the terminal bell noise, they actually use that to replicate an FT8 signal, is what I'm hearing. Or is what I'm getting from that.
Yeah.
So interesting.
Sounds
Not
right.
completely pointless, but there you go. So anyway, thanks for that, Coase. But we have, I think it's Coase because I think the double O's is O, not ooh, but who knows? You just say it however the hell we want. I'm just glad we have feedback. And we'll go ahead and let Cheryl read the second one from Coase or however you pronounce it, who has been, by the way, a very long time listener. I don't remember when he started listening, but it's many, many years now. So go ahead and read the last one we've got here.
Okay, and our next one from Coase or Coase, however we're going to pronounce it, says, maybe not news due to my podcast backlog, but another gem popping up on Twitter. And again, the long Twitter link. And he goes on to say, using DMR from the computer, it doesn't want hotspot or radio. You just need to have your DMR ID number. It's that simple. Download the latest version. It points to the Windows version, but is Linux, Mac OS, Windows software from GitHub link. Of course, all these links will be in the show notes. It says software to RxTX, DStar, DMR, Fusion, YSF, FCS, blah, 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 all over UDP. It says the software connects to DStar, Fusion, et cetera, et cetera, et cetera, all-star nodes. It's compatible with the AMBE 3000 based USB devices out there, Thumb DV, DV Stick, 30 DVSI, etc. It includes software decoding and encoding support using experimental open source IMBE, AMBE vocoder software. This software is open source and uses a cross-platform C++ library called Qt. It will build and run on Linux, Windows, and Mac OS X. So now that's good LHS news. Keep up making podcasts. If this item makes it into your podcast, I'll hear that around April at my current podcast backlog rate. Coase or Coase, P4KH.
Very cool. And I'm hoping that at some point I can do a deep dive on this. There were two sort of really interesting things I found about this particular article or this particular Twitter post. One is that it uses an Ambi chip on a USB stick if you want to, like the DV Stick 30, which I'm hoping to pick up one of these days so I can actually do some of this stuff and maybe connect it to my YSF gateway so it can actually transcode DStar. And the other thing is, several references here to the fact that it's going to support M17. It's kind of interesting, and I'd like to see where that follows through. So hopefully at some point we can do a deep dive into this project, which is called DudeStar, and it will be linked, of course, into the show notes. So thanks, Coase, for your emails, and hopefully you'll get a chance to listen to this before April. But if not, I guess we'll hear from you again then. And thanks very much for sharing these because they're both really interesting. Again, I'm not sure about the utility of FTH Signal using the bell command, but the other one seems really, really interesting to me. So I'm looking forward to checking that one out. So I guess that brings us down to the end of the show. Let's check in with the folks who are listening in the chat room tonight, see if they have anything else to say to us. And we'll go ahead and let you know who those folks were tonight. While we're waiting to see if anyone has anything to say, we had Don, KC9ZMY, Tony, K4XSS, Don, KB2YSI, Ted, WA0EIR, Dan, KB6NU, Steve, KA7HVT, and Gene, BX8AAD. So like a full house here tonight. If nothing else shows up in the chat room here in the next 30 seconds while I'm rambling on a bit, then I guess we're going to go ahead and wrap up this episode, unless anyone else has anything they need to announce before we go ahead and close. Dit from Ted. So, all right, let's go ahead and call it a show. Thanks everybody for listening. This has been a deep dive into setting up a proper build environment on your Linux machine. Hopefully we've taken some of the mysticism and some of the fear out of building software under Linux. It's really not that difficult, and we hope you give it a try at some point. In the meantime, we hope you have a great week and tune into the show next time around when we release episode number 388. In the meantime, hope all is well, and we'll talk to you soon. This has been episode number 387 of Linux in the Ham Shack. I'm Russ, K5TUX.
I'm Cheryl, W5MOO.
And I'm Bill, NE4RD73.
Thank you for listening to this episode of Linux in the Ham Shack. LHS is a community-sponsored podcast. The live show is recorded every Monday night at 8 p.m. Central Time, plus or minus QRL. Connect to the live stream at url.bcts.info/LHS Live. Our website is located at lhspodcast.info. You can support the podcast by visiting the LHS Patreon page at patreon.com/LHS podcast, or by using the contribute link on the homepage. Get in touch via social media. We have a presence on Discord, Facebook, IRC, Twitter, and YouTube. Our IRC channel is #LHS podcast on the Freenode network, and the Discord invite link is url.bcts.info/Discord. You can also drop us an email at info@lhspodcast.info or leave us a voicemail at 1-909-LHS-SHOW. That's 1-909-547-7469. Visit the online LHS merchandise store at shop.lhspodcast.info for fun and fashionable show-themed merchandise. Become an ambassador and represent LHS at a local Linux convention or Hamfest. Email ambassadors@lhspodcast.info for more information, or visit the homepage for details. Until next time, remember to always heed your hedonism. Linux in the Ham Shack and the Linux in the Ham Shack logo are released under a Creative Commons Attribution Non-Commercial No Derivatives 4.0 International License.